Imagine a scenario in which, by 2026, an average person could have access to an electric plane for less than the price of a luxury SUV. It may seem far-fetched, but this is one of the boldest projections associated with Elon Musk's name. While Tesla has never officially confirmed the production of an electric aircraft, Musk has hinted in past interviews that he's been considering the concept for years. He mentioned the idea of a VTOL, vertical takeoff and landing, jet with electric propulsion and a futuristic design. And when Elon speaks, the world listens, because he has a habit of turning absurd ideas into commercial realities. It was the same with cars, with rockets. Why not with airplanes? Given the existing Gigafactory structure, some analysts believe Tesla could adapt its automation expertise to mass-produce aircraft. A potential Giga Air, modeled after a vehicle factory, could manufacture up to 12,000 units per year, optimizing the process with robots, artificial intelligence, and high-precision machinery. The assembly line logic that has brought down the costs of electric cars could theoretically be applied to the aviation sector, a market still stuck with expensive and slow artisanal production methods. This would open up space for a plane estimated to cost in the region of $79, $597, something completely outside the standards of traditional aviation. But where would such absurd savings come from? One of the bets would be the adoption of Giga presses, giant machines that Tesla already uses to cast entire car parts into a single piece. In theory, an adapted version of these presses could be used to manufacture an aircraft fuselage, reducing assembly time by up to 65% and structural costs by over 50%. This would eliminate the complexity of hundreds of hand-fitted parts, replacing everything with large blocks molded with millimeter precision, something that would completely change the logic of cost and maintenance. Another factor fueling this projection is battery developments. Tesla has been investing heavily in new chemistries, and one of the most frequently mentioned behind the scenes is aluminum-ion, much cheaper and more abundant than lithium. If these batteries truly reach maturity by 2026, the cost per kilowatt-hour could drop to $45, well below the current industry average. For an airplane with a 100 kWh battery, this would mean savings of $6,500 in the power cell alone. Furthermore, with enough density to fly 300 miles, this hypothetical model would cover 97% of U.S. domestic routes on a single charge. Now imagine that same aircraft being affordable not only in terms of purchase price, but also in terms of use. One idea circulating among analysts is a SkyShare model, a shared ownership system in which users could pay a monthly fee to use the aircraft on demand, like an Airbnb of the skies. This would not only reduce operating costs, but also increase viability for companies, flight schools, or small business groups. At around $4,500 per month, maintenance, recharging, and even insurance could be shared, taking the electric plane out of luxury and into everyday life. This possibility would be a direct blow to major manufacturers still stuck in conventional business models. Boeing and Airbus, for example, focus on large, expensive aircraft for major airlines. But an affordable and compact Tesla aircraft would serve a different audience: people who need fast, hassle-free, regional air mobility. This approach would allow mid-sized and large cities to connect without relying on crowded airports, lines, or tiresome layovers. A direct, quiet, and affordable flight departing from a helipad or even a dedicated parking lot could be a viable alternative. It's worth remembering that these ideas don't come out of nowhere. Musk has publicly stated that he has a complete design for a VTOL electric jet in mind, but that he hasn't yet implemented it due to priorities. The technology, he says, already exists or is close to it. What's missing is focus. And if Tesla's history has taught us anything, it's that when the company decides to focus on a project, it executes it with brutal speed. The Model S was criticized as impossible in 2012. Today, it's a benchmark. The same trajectory could be repeated in the skies. The only thing holding this plane back from becoming a reality is time. The technology is aligning, the industrial infrastructure is ready, and the market is increasingly demanding sustainable, fast, and affordable alternatives. If Tesla decides to cross that line, the first step has already been taken. And everything indicates that, when that happens, it won't be with an ordinary plane. It will be with a model that costs less than a luxury car and flies like no aircraft in its class has ever flown. If there's one obstacle that has consistently thwarted dreams of a viable electric plane, it goes by a specific name: weight. More precisely, the weight of batteries. While combustion-powered planes become lighter as fuel is burned, electric models need to charge their batteries from the beginning to the end of the flight, without losing a single gram. This is the kind of problem that can't be solved with willpower or marketing. It's pure physics. But if Elon Musk is to truly bring the Tesla concept to fruition, this challenge will need to be overcome with a blend of advanced chemistry, structural engineering, and bold design. This is where speculation about the use of aluminum-ion batteries comes in, a technology Musk has already expressed interest in, and which has a higher energy density than conventional lithium. If successfully applied in aviation, these batteries could offer 6 kilo weight but books compared to the 0.11 kilo weight of current batteries. For an estimated range of 1,300 miles, the total weight of the battery would be around 1,984 pounds, almost half of what would be required with traditional lithium. This drastic reduction in mass changes the entire mathematics of flight, making possible something that, until recently, was considered impractical. But reducing weight isn't enough. The plane would need to be designed to withstand the continuous stress of carrying this load throughout the flight. That's why many projections point to a carbon fiber fuselage, with reinforcements inspired by the Cybertruck's exoskeleton. Tesla has already proven its ability to work with advanced alloys, and with the collaboration of SpaceX, which dominates aerospace composites, a lightweight and durable plane seems more a matter of engineering than imagination. It's estimated that such a fuselage could save plus 661 pounds, alleviating structural impact and facilitating safer landings and takeoffs. Furthermore, to balance the weight of the batteries, the design could be inspired by the Cybertruck's distributed architecture. Instead of concentrating all the mass in the center, the plane would distribute the weight horizontally, avoiding pressure points on the landing gear and reducing weight by up to 30% downforce during landings. This extends the life of mechanical components and ensures a smoother landing, even on improvised runways or urban vertiports. Every detail counts, because any excess pressure in poorly calculated areas can be costly in a project of this scale. Another notable point in the projections is the use of ultra-compact electric motors integrated into the vertical landing system. This would not only help reduce weight at the ends of the aircraft, but would also allow for an additional weight reduction of approximately 331 pounds in the overall structure. And because the motors are powered directly by the high-discharge cells of the StarVolt batteries, the system could use the deceleration of the flight itself to regenerate some of the energy, similar to the regenerative braking in Tesla electric cars. This function could recover up to 18% of energy used, increasing range, or reducing the required battery size. Thermal efficiency would also be a huge differentiator. One of the main advantages of aluminum-ion is its thermal stability, which eliminates the need for heavy cooling systems. In theory, this would save up to 265 pounds that, in traditional models, would be dedicated to ducts, radiators, and cooling pumps. And less weight means more range. In an electric plane, where every kilogram can be the dividing line between success and failure, this advantage is invaluable. It's no wonder that companies in the sector are increasingly paying attention to this chemistry. And if artificial intelligence enters the picture, optimization could go beyond the physical structure. With the support of Tesla's own Dojo supercomputer, the plane could adjust variables such as angle of attack, flaps, and engine torque in real time. This would allow for structural load relief during critical moments, like takeoffs and landings, without compromising safety. AI would make decisions in milliseconds, reducing the need for extra parts or excessive reinforcements that would increase weight. It's the kind of dynamic control that, until recently, only existed in military fighter jets or state-of-the-art simulators. In aviation, no technical advancement is sufficient without a safety check. And when it comes to a futuristic electric plane, even if only in projections, the first point skeptics raise is this: would it fly under the strict eyes of the FAA? The answer, based on Tesla's track record and what Elon Musk has already said publicly, is that the company probably wouldn't enter this game without a robust certification plan. After all, we're talking about an industry where even the slightest deviation from the norm can pose a real risk. And Musk, despite his boldness, understands the importance of following the rules when it comes to human life. Considering the type of battery that could be used in this hypothetical aircraft, the advantage of an aluminum-ion system is also clear. Unlike lithium, which is highly flammable, aluminum-ion uses non-volatile electrolytes, making it 99.8% non-flammable. In laboratory tests, these batteries withstand extreme temperatures, from 58 degrees Celsius to 176 degrees Celsius, no explosions, no leaks, and no spontaneous combustion. This type of behavior would be a crucial asset when facing FAA certification tests, which are known for their brutality and demands. Another factor that would weigh in Tesla's favor in a real-world scenario would be the construction of its own test centers in the United States, something the company already does for its vehicles and which could easily be adapted to aviation. Such an initiative would create jobs and bring the brand closer to regulatory agencies, paving the way for an eventual FAA Part 23 certification, which regulates small aircraft. It is estimated that an investment of $15 billion facilities and infrastructure would be enough to ensure that the project gained legitimacy without depending on third parties. But the battery wouldn't be the only thing that would ensure safety. On board, this aircraft could also have a dual power system, 2 independent star-volt batteries operating in parallel, and quadruple redundant flight controls, a common practice on modern commercial aircraft. This would allow the plane to continue safely even if 2 of the 4 control layers failed. Such a feature is vital in emergency situations and would increase the confidence of regulators and, of course, passengers. Now imagine this safety being enhanced by artificial intelligence. Tesla has Dojo, its supercomputer trained on billions of miles of road data, which could easily be adapted to analyze in-flight behavior. Instead of relying solely on human perception, the system could predict turbulence, collisions, and failures with up to 85% more accuracy than an experienced pilot. This would allow critical decisions to be made in advance, reducing risk and increasing control at every stage of the flight. Another detail that's often overlooked but makes all the difference when it comes to obtaining certifications is physical protection. This aircraft, if it follows Tesla's standards, could feature ultra-resistant glass similar to that used in the Cybertruck, withstanding impacts equivalent to 5 times the total weight of the aircraft. In addition, the batteries would be encapsulated in a casing reinforced with Kevlar, the same material used in bulletproof vests, capable of absorbing 50% more impact energy than conventional lithium compartments. In the event of a collision, the containment system would prevent fire or toxic gases from entering the cabin. And speaking of the cabin, it wouldn't be surprising if it were equipped with smart sensors capable of detecting electrical faults, excessive heat, or sudden pressure changes in real time, all integrated into a central control panel based on certified aeronautical software, with constant remote updates, something Tesla has been doing with its cars for years. This type of system would drastically reduce the risk of sudden breakdowns and facilitate routine audits, as the entire operation would be recorded and available for analysis. Putting all this together, ultra-stable batteries, energy redundancy, predictive artificial intelligence, reinforced armor, and an internal testing ecosystem, the scenario stops sounding like fantasy and starts to sound like a well-structured long-term plan. Even without any official confirmation, Tesla's track record of challenging and overcoming bureaucracy with innovation gives rise to the belief that, if this plane ever comes to fruition, it will be ready to meet the highest safety standards in modern aviation. An airplane may be revolutionary on paper, but if it's not practical in everyday life, it becomes nothing more than a technological museum piece. And when designing a Tesla electric aircraft, even hypothetically, it's impossible not to think about how it would work in real life. Taking off, landing, charging, and offering a comfortable onboard experience. After all, what good is all the engineering in the world if flying remains slow, uncomfortable, and bureaucratic? The good news is that if Elon Musk does decide to enter aviation, he would already have all the pieces to build a practical, efficient, and, above all, functional operating system. Let's start with the basics: takeoff and landing. The most widespread idea among enthusiasts is that Tesla's electric plane would VTOL capability, meaning it could take off and land vertically, like a helicopter. This changes everything. Instead of relying on long, congested runways, it could use helipads, rooftops, or adapted parking lots in urban areas. This flexibility would allow it to connect mid-sized cities without the need for traditional airports, cutting travel time and making flying as simple as ordering a ride through an app. In terms of reach, the estimate is around 1,300 miles on a full charge, which covers 97% of U.S. domestic routes in practice. This would mean flying from Dallas to New York, or from Los Angeles to Seattle, non-stop. And with the expected advancement of aluminum-ion batteries, this range would come with fast recharging, 80% in 30 minutes using the mega chargers, derived from Tesla's own electric truck technology. This would allow up to 5 flights per day with a single aircraft, transforming the model into a true workhorse of the skies. On board, the idea would be to offer an experience worthy of a flying luxury car. Ergonomic seats with body memory, automatic adjustment via facial recognition, and even a smart climate control system, all managed by an AI interface based on Tesla's already well-known platform. Instead of buttons and switches, passengers would use voice commands to adjust lights,